Hi, welcome back to season 5 of QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to talk about quantum computing education, which is a super important topic and near and dear to my heart. And we will also get some updates regarding Azure Quantum. And for all of these exciting things, I'm honored to have a very special expert guest today, Mariia Mykhailova. Hi, Maria, and welcome to the show. How are you today?
A pleasure to be here.
All right. So thank you for joining us. Can you tell us a little bit about yourself and your background as it relates to quantum computing?
Of course. So these days I'm a principal software engineer at Microsoft Quantum, focusing on education and outreach. Surprisingly, I've been in quantum computing only for the past 5 years. Uh, Originally, I'm from Ukraine. I got a master's degree in computer science there, and while it had a surprising amount of physics in it, um, having quantum computing as a career was just not something that occurred to me at that point. So I went a very indirect route, spent about 5 years in banking software industry back in Ukraine, then moved to US, joined Microsoft, and spent another about 5 years in cloud computing infrastructure teams. And everything I know about quantum computing, I actually learned after joining Microsoft Quantum team.
Oh, that's definitely impressive. How you basically a self-taught quantum engineer kind of a thing, and that's also very good way to approach the topic, right? Is like you're a software engineer, and now you want to work on quantum. And so let's talk a little bit more about the educational part of it. But first let's talk about some of the Azure Quantum updates since you work at Azure Quantum, right? So in QBite season 1 to 4. We already talked with a few of your colleagues like Anita, Bettina, Vincent, Chris, Fabrice, Kitty, and also MVP Dr. Sarah Kaiser, and a lot of other folks about Azure Quantum. But it's been a while since we talked about Azure Quantum, but also the QDK, Q Shop, and all the other goodies. So can you tell us a little bit what happens since the last time we talked in the Azure Quantum world? Any updates since last year?
Yes, we actually got quite a lot of exciting updates in the past half a year or so. And talking about them chronologically, I guess, we started by rolling out support for Qiskit and Cirq when submitting jobs to Azure Quantum. Basically, we figured out that a large share of quantum computing community starts their quantum computing journey with Qiskit. And we figured out let's make them feel welcome in our ecosystem. So we added this support, and we already see that a lot of Azure Quantum usage comes from Qiskit users. Second, we announced that we are increasing our pool of hardware providers. You probably know that we started with two partners, IonQ and Honeywell, which is now Quantinuum. And then we are working with QCI to add them to our offerings. And the latest news is that Rigetti will be joining us sometime, hopefully very soon. And the last piece of news, probably the most exciting for your audience, is the new Azure Quantum Credits program. Uh, so now, and we announced it just in February, anybody can just register for Azure Quantum and use $500 in credits for each hardware provider to just play around, experiment, see what it looks like. And then if you are doing something more in-depth, a larger project, some research maybe, or possibly teaching a quantum computing user using Azure Quantum, you can apply for a larger grant up to $10,000 to use that sponsorship in your work.
That's quite a lot of money, in fact. So you get 10K for sponsorship, but even without having to fill in a lot of documents, you can get $500, right, as a credit for running quantum algorithms on real quantum hardware through Azure Quantum, right? And so, ooh, that's pretty exciting. So we can go get all our first kind of quantum hello world, not just run in a simulator, but you can actually try it out on real hardware. Wow, that's amazing. Thanks for sharing that, Mariia. It's really good stuff. So folks, just go to Azure Quantum, I guess, and get the $500 credits, right? But let's talk a little bit more about another topic about the educational aspect of quantum, because this is, of course, a very important thing because the field is still growing and there's, doing QuBites. I mean, we're recording here for season 5, right? So I've been talking with a lot of folks, and a reoccurring theme is definitely the kind of skills gap that is currently there, right? There are just too less people that are skilled to work with quantum computing and so on, right? And so you work also a lot of on educational part and also on the future for quantum developers, right? So, for example, you're involved with the Azure Quantum developer workshops, which I all attended. And I have to say, Mariia, when I saw you first in one of these quantum workshops, you really explain it so well. For example, all the gates, for example, right? Some of the basics, like everyone takes for granted, but you explained it so well visually and a lot of amazing things. So, anyhow, what I just trying to say is amazing workshops you have done. And if you guys have not seen it, definitely try to catch a recording and make sure to attend some of the future workshops, right? But anyhow, what else are you doing in the quantum educational field, and what can you recommend for folks to get started actually?
Oh, you just stumbled upon one of my absolutely favorite topics in quantum computing. So, I joined the team actually as a software engineer to work on the compiler for the quantum programming language, which eventually became Q#. But after the first year or so, when we released the first version of the quantum development kit, we started to look at the patterns of usages for it. And it turned out that people are super excited about it, about quantum computing, trying to write something interesting in it, but they don't know how to do it. Of course, because when you're writing Hello World in Python and then you want to switch to C++, it's relatively easy. It's the same principle. But to write a Hello World in quantum computing, it's completely different from what you've seen before. So you need to do quite a lot of learning to get to the point at which you can do something interesting. So I started looking at this and figuring out how to help people without quantum computing background learn quantum computing. And that's how I came up with my first project that actually landed me in this education and outreach work, the Quantum Katas. It's about 3.5 years old at this point. It's a collection of programming exercises and then later tutorials that help you learn quantum computing, not just by reading or listening to things or watching videos, but by solving problems, implementing them, and most importantly, immediately getting feedback on your solution.
Yep.
I personally believe that you cannot really master a concept or an algorithm unless you actually implemented it. One of my favorite anecdotes is a time when I tried to implement Grover search at first. And coming from completely classical background, of course, I figured out that the more iterations you do with this search, the better the result's going to be. Took me a couple days to figure out why I'm doing all those nice iterations and the result doesn't make any sense. Precisely because it is a quantum algorithm which behaves completely differently from classical algorithms. So I'm a huge believer in implementing things to understand them, and the katas effectively reflect this. And this project is actually my favorite recommendation for getting started. It starts with the complete basics, not even quantum computing, but the math you need for quantum computing. So the complex numbers, the linear algebra tutorials. And then it goes into what the qubit is, what the gates are, and all of these topics are accompanied with programming problems that you can solve. And then they go into quite interesting and rather deep topics that are often not covered in the introductory materials. For example, quantum oracles. It's a fundamental part of a lot of quantum algorithms. But again, when you see a blog post or a book chapter on Grover's algorithm, very often it just says, we have an oracle. It doesn't actually go into how you get an oracle, how you take a problem and convert it into an oracle that you can then feed into Grover's search algorithm. And that makes the algorithm completely different. You start thinking about it differently. You understand that the speed up it offers might not actually be practical, and you need to look for algorithms that offer you better speed up to get something out of quantum computing. So a lot of good stuff in there. Then what else do I do? As you have mentioned already, workshops, Azure Quantum Developer workshops, hackathons, programming competitions, basically all kinds of things to make learning quantum computing, experimenting with it really exciting and fun. Because we all know it's easy to tell yourself, I'm going to learn quantum computing, but it's really hard to get started. You need this a little extra push, and ideally this push should be fun. And finally, a big area of my focus is learning quantum computing at universities. I was part of the course that our team taught at University of Washington a couple years ago. And then I taught a course myself at Northeastern University in Seattle. So I have some first-hand experience with this. It turns out I really love teaching. I wouldn't have thought it before I tried. So one of the interesting things we do with this first-hand experience, we basically package the curriculum materials we developed for these courses in a nice kind of bundle, including programming assignments, automatically graded ones. There's no way I'm grading students' assignments by hand. And we share those curriculum materials with folks who want to teach quantum computing at universities in this kind of hands-on, very practical way. So if you happen to be a professor who wants to teach a class on quantum computing using Quantum Development Kit and Azure Quantum, reach out to us and we might have some very nice things for you.
Nice. Nice. So, folks, take her up for the offer here. That sounds good. And you heard about the automatic rating, right? So, man, that's a time saver. Only that fact should sell it, kind of. Well, you're not selling it, but well, awesome. And yeah, really interesting. Also, what you said, like you gotta really implement it to understand it really in depth. And the next thing is actually like you didn't say it, but implicitly, kind of like if you really want to understand it, you got to teach it, right? And that's what you're doing, right? It's like you got to dive, like if you can explain it in simple words, if you can teach it, then you really are an expert in the topic. And so, well, thanks for being here, because like apparently that's a really amazing expert level here for sure, that you're teaching a course at a university. And you're also writing a book, which is called QShop Pocket Guide: Instant Help for QShop Developers, which sounds really amazing, because like who doesn't love an instant help, right? And so yeah, I'm sure I want to get a copy. So tell us a little bit what's in there, and can we pre-order it already, or what is the kind of timeline?
Yeah, that project is my COVID puppy, I guess. That's what you do if you're allergic to anything cute and fluffy. You start writing a book. So it's basically a book that covers two main topics. First, the Q-sharp language itself. So the first part of the book is basically an extended syntax reference. So it covers all things from the program structure, data types, expressions, statements, and pretty advanced topic actually, all the interesting things that Q-sharp offers for implementing quantum operations. So all kinds of things like partial application, adjoint and control variants of operations, um, kind of things that are not necessarily part of any programming language that you have seen before, but that come extremely handy when you are implementing quantum programs. And then the second part of the book focuses on Quantum Development Kit. So it covers topics such as quantum software engineering workflow, the simulators you're going to use as part of this workflow, developing unit tests for your quantum programs. A topic very important. We are all software engineers. We know how important unit tests are, but very different from classical testing. So
Non-deterministic unit testing, are you saying? Is that the kind of thing?
sometimes it's using clever built-in tools to get a peek at the state of the quantum program without measuring it. So it's a
Mhm.
completely non-physical thing to do. You wouldn't be able to do it when running on an actual quantum device. But when running on a simulator, you can do a little sneaky thing to make your tests actually deterministic. Tools for debugging and visualizing the programs, also very important, especially for learning. And the libraries. Quantum Development Kit has quite a lot of libraries, which I feel don't get the attention and the love that they deserve. So I tried to give them a little of both in my book. So I think it's a lovely book if you're a C# developer. And it's actually available for pre-order already at Amazon. It's not yet available for pre-order at O'Reilly website itself, but it's there in early release. So if you have the O'Reilly subscription, you can just go ahead and start reading.
Well, so basically following you while you write it, actually, and then you get new pieces, huh?
Yes, we started with publishing the first chapter probably 4 months ago, and now I'm actually done with writing the main part of it. Was just putting the finishing touches on the last few chapters this weekend.
Now we go live action here. And so yeah, folks, go and pre-order it. It sounds like it should be coming out in a few weeks or months or so. You know how all of this works with publishing. There's a bit more time to add on top of it, but definitely sounds like an amazing book where you basically first teach the language and then show how to use it and implement good stuff with it, and also talking about the unsung heroes of QDK, kind of, right? Like, well, we're already at the end of the show. Thank you so much, Maria, for joining us today and sharing your insights and about your book writing journey and all of it. That is very much appreciated. Thank you so much for being here with us today.
Thank you for inviting me.
Well, and thanks everyone for joining us for yet another episodes of QBites, your bite-sized pieces of quantum computing. Watch our blog and follow our social media channels to hear all about the next episodes. And of course, you can watch all current and also previous episodes from season 1 to 5 on our website. So take care and see you soon. Bye bye.